In this video, I'm going to talk about prime numbers and factor trees. Now, a prime number can be defined as an integer whose only factors are 1 and itself. Now note, an integer is a whole number. It's not a decimal and it's not a fraction. An integer is a whole number, and the factors are 1 and itself in a prime number. So here are the first 8 prime numbers, and you'll notice that 1 is not a prime number. 1 is a special number. It's not a prime, it's not a composite, but 2, 3, 5, 7, 11, 13, 17 and 19 are all prime numbers. They can only be divided by 1 and themselves. Now, another definition that we need to think about is the word factor. And a factor is a whole number that divides exactly into another whole number with no remainder. So here we have 30 divided by 6 gives us 5. So there's no remainder, therefore 6 is a factor of the number 30 and 5 is also a factor of the number 30. Now, the factors of a number can be found using factor pairs, and one of the pairs may be a single number which is multiplied by itself. So here is a factor pair of 24. 4 times 6 is 24. So 4 and 6 are the factor pair. So you may have 4 times 4 is 16, so that's a factor pair 4 times 4. That's where it's multiplied by itself. And a factor tree shows the prime factors of a composite number. We're going to explore factor trees and prime factors right now. So we're going to do that first of all for the number 60. And the way that we go around doing this is, first of all, write the number 60 at the top of the page. And then we choose a factor pair, two numbers that multiply together to give the number 60. So I'm going to choose 2 and 30. So 2 times 30 equals 60. Now 2 is a prime number. 30 is a composite number, so we can therefore get another factor pair from the number 30. So 2 times 15 is 30. So 2 is a prime number and 15 is a composite number. So we can break down 15 and we can do that by 3 and 5. 3 times 5 is 15. Now, all of these numbers in the green circles represent the prime numbers that multiply together will give us 60. And we can write that in this way. 2 times 2 times 3 times 5 equals 60. So you can calculate that out for yourself if you like. Now let's do another example. We'll do a prime factor tree for the number 72. So again, we'll write the number 72 at the top of the page and we'll break it up first of all to factor pairs of 2 and 36. 2 is prime, 36 is composite. We can break 36 into 2 times 18. 2 times 18 is 36. 18 is composite, and we can get 2 times 9. 2 times 9 is 18. 9 is composite. We can break that down into 3 multiplied by 3 is 9. We now have all of our prime numbers. We can't break it down any further. 2, 2, 2, 3 and 3. So we can write down our prime factors are 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 3 equals 72. Now I will ask you to pause the video here and draw yourself a factor tree for the number 24. Alright, now there are a number of ways that you can do it, but you're going to end up with the same answer. So one way that you might have done it is 24, break it down to 4 multiplied by 6. 4 multiplied by 6 is 24. The factor pairs of the number 4 would be 2 multiplied by 2, and both of those numbers are prime. The factor pairs of the number 6 are 2 multiplied by 3. So our prime factors for the number 24, 2, 2, 2 and 3. So you would write that as 2 multiplied by 2 multiplied by 2 multiplied by 3. Now, you may have chosen to do this in a different way. So 24, you may have said that 2 multiplied by 12 is 24, which is acceptable as well. So 2 times 12 is 24. We can then break down 12 into 2 multiplied by 6, and then we can find the composite of number 6 is 2 and 3. So our factor pairs would be 2, 2, 2 and 3. So that was exactly the same as we found in the previous factor tree.